My name is Art. I am the Developer Relations Manager here at Sencha. And I've been working in web development for most of my life at this point. So I'm still fairly young, but I built my first website when I was probably 13 or 14. Everyone think back to when Yahoo GeoCities was a thing. I was on that pretty much every night, building websites. And since then, I've had my head down in my browser, building websites, applications. Obviously now we're building web apps with Sencha technology. So if you want to learn more about me, you see my website, akawebdesign.com, or you can follow me on Twitter. So today's presentation is really the story of why I built a Chrome extension, how I built a Chrome extension. And more importantly, why I thought that was a good idea. I'm going to start by introducing to you a lot of what you already know with Google Chrome's developer tools. We're going to cover some basic and advanced, even some hidden features of Chrome developer tools. Before we dive into building a Chrome extension, and I'm going to showcase an example to you, something that I built a little over a year ago called App Inspector for Sencha. Anybody use that? Woo, okay. I'm going to explain to you how that works under the hood so you can get a better sense of why building a Chrome extension can be very helpful to you. And assuming we have lots of time toward the end, and I'm going to try to rush through the start of this so we can, some of you may have seen this thing called Sencha Inspector in the keynote that grew out of the Chrome extension that I built, and I'll highlight some features and talk a bit more about that. So let's talk about Chrome developer tools. Most of you already said you're familiar with that. And let's do a little history lesson. Chrome was first released in 2008, and what I find fascinating about just that fact alone is that the iPhone has been around longer than Google Chrome. I'm so attached to my phone today that it's hard to believe that the iPhone is older than Google Chrome. And Google Chrome quickly gained a lot of market share among our demographic, people working in web development, because it was fast, it was cool, and it shipped with some developer tools that were better than what we typically had before. So you think of the landscape of browsers in 2008. Shout it out if you can guess. What was your primary debugging tool at that point? Firebug, thank you. Anyone still use Firebug? Wow, more people than I expected. Okay, so Firebug was an awesome tool, still is a really good tool, and certainly at the time, Firebug was light years ahead of anything you got out of the browser. But when Google Chrome was released, it extended Safari WebKit. So out of the box, you got the Safari WebKit debugging tools, which were fairly limited, but very quickly, the Chrome development team began iterating and adding features to that. Fast forward to about 2010, and they moved to 6-week release cycles. So today, whether you like it or not, every 6 weeks you get a new version of Chrome. That includes a new version of developer tools, and what's important about that fact is that whether you like it or not, the Chrome developer tools team may decide to add or remove or hide features at any given time. And at this 6-week cadence, it can be somewhat frustrating for us to rely on a particular subset of those tools only to have them change without much of an explanation. So currently, well, as of the other day when I looked, we're at version 41 of Chrome. I'm not going to spend too much time talking about the basic features. I think most of us are familiar with things like our Elements tab, where you can inspect your DOM tree. The Network tab, you can see any network requests that are moving across the wire. For those of us building Sencha applications, you all probably spend a lot of time in the Sources tab, actually setting breakpoints and inspecting the JavaScript runtime directly. Your Resources tab allows you to view any data that's stored locally in the browser. So this could be cookies, this could be local storage, local database, session of some kind. And then finally, your console, in which you can execute arbitrary JavaScript. So far, I haven't told you a single thing you didn't already know. But when we get into the advanced features of Chrome developer tools, what you'll notice is that even though these are some features that are not hard to find, your Audits tab is just sitting there, and you can click on it, and you can try to figure out how to use it. But many of the advanced features are not well documented. They're not easy to understand how to use. They're not easy to infer information from. And there are some scenarios in which you may want to use some of these more advanced features. So your Audits tab is very similar to a tool that came out years ago with Firebug called YSlow, in which you can analyze something like 32 different performance metrics on a web page. And the Audits tab essentially does that. You can ask Google Chrome to audit what's happening in your web page, and it will tell you need to combine your JavaScript files or move the script tag to the bottom. Maybe you need to gzip everything coming off the server. All of these things will impact your web page load performance. The timeline is an awesome place to analyze what's happening at the browser level. So if there are any elements that are rendering or repainting on the screen, there's a lot of good information there. But again, it can be tricky to figure out how to do that. And I'm not going to dive into an example here because I want to get to the meat of my presentation. But for those of you who may have been at SenchaCon 2013, or if you've watched the videos on our Vimeo channel, Jamie Avens did a great presentation in 2013 on using the timeline with the Sencha Touch application, and gives you a handful of concrete examples and debugging issues with jaggy scrolling or animations that aren't very smooth. So that would be what the timeline would be very useful for. The Profiles tab. Does anybody here use the Profiles tab on a daily basis? Handful of you. Okay. Profiles are an extremely advanced area of Chrome developer tools. And I would say that every day I probably don't use profiling, but maybe once a week or every couple of weeks, profiling can be very useful at the CPU level. And an example might be if you've got an application running in IE 8 and all of a sudden your browser freezes because the JavaScript runtime is just eating up CPU cycles. You might want to jump into Chrome and use the CPU profiler to identify what section of the call stack is taking up a mammoth amount of CPU cycles. So one example might be if you've got a data store with thousands of records in it, you might want to profile the CPU performance while you're sorting or filtering. Perhaps your filtering algorithm isn't the most optimal for that data size. Now, the CPU profiler won't tell you that's the problem. You may need to infer information from what it gives you, but that would be the area to look for situations like that. What I'd like to do would be to identify a few hidden gems that I find in Chrome developer tools, things that at least help me as I'm building things internally at Sencha. And these are items that I call hidden gems because if I had to throw a number out and guess how many individual features Chrome developer tools has, I would guess somewhere in the range of several thousand. There are literally so many features of Google Chrome, they ran out of space to put them, and so they hide them from you. And these are a handful of examples, and I'm going to jump into my browser and showcase them for you right now. So the first item I want to take a look at is the Layers tab, which is hidden under this area called Experiments. And the first thing you have to do to find your developer tools experiments is to go into Chrome://flags. And one flag you need to turn on is Enable Developer Tools Experiments. So you hit the Enable link. You need to shut down Chrome and then reopen it, at which point you can come into Chrome Developer Tools, hit your settings, and over here you'll see an Experiments tab with a whole bunch of options. One of these, and actually let me jump to a different application. One of these is called the Layers panel. And frustratingly, you also now have to shut down Chrome Developer Tools and reopen it. But magically, we get this new Layers tab, which is sitting right there. And what's great about layers is that if you're doing things with CSS3 transformations, you can get a three-dimensional view of the DOM structure. And if you follow the Sencha blog at all, you probably see my name up there a lot. In the summer of last year, just for giggles, I created the new layouts because for some reason I figured everybody cared about how to build their own custom layouts. So I created this nifty three-dimensional carousel of Sencha Touch components. And what would be helpful in the case of something like this, obviously I'm creating a three-dimensional shape. Perhaps I want to see how those panels are laid out in three-dimensional space. And so the Layers tab gives me a nice little diagram of what that looks like. And what's cool is that you can actually rotate it around so you can, well, it's kind of hard to see. Oops, that's what I'm doing. So you can get different views of the three-dimensional space, or if you've got lots of DOM elements stacked on top of one another, it'll show you that. So you can see what areas of the DOM are really heavy versus the really light areas. So that's a really cool tab that I would encourage you to start playing with. The next item I wanted to highlight is the escape drawer. So as somebody who spends a lot of time in my sources tab, perhaps I want to take a look at my app.js file. And just maybe I put a breakpoint in, and at some point in the runtime I hit this breakpoint, I want to start utilizing my JavaScript console. The workflow is that you'd have to now click over to the console and do your thing, and then you come back into sources and you start inspecting the variables, and the jumping back and forth can be rather frustrating. So you can hit the escape key, and from the bottom pops open this drawer. It's called the escape drawer, in which you can now see a JavaScript console. I can type in any arbitrary JavaScript I want to, and it executes. And it is exactly the same console you see on the console tab. So that's great for just convenience, but what's even better is that there are 3 additional tabs next to console in my drawer. I'm not going to talk about search, but there's an emulation tab in which if you wanted to do some quasi-realistic debugging of an application as if it were on a mobile device, I could select, say, an Apple iPad. And I can refresh this and hit that breakpoint. And now it has resized my screen to be the dimensions of the iPad. It has also changed my user agent, because clearly sniffing the user agent is the best way to detect what mobile device you're on. But it also switches to mobile events. So when you're building an app with Sencha Touch is smart enough to switch between desktop mouse events and touch device touch events. So you can see rather than a mouse, I'm now given this cool little circle, and I can do my touch interactions that way. So that's an awesome feature. If that weren't already great enough, you can, under the Rendering tab, look at all sorts of other really useful information. So if I turn on Show My Paint Rectangles, what this can be good for is helping to identify sections of the user interface that are getting repainted whenever something happens on the screen. And you'll see these little green boxes anytime I interact with something. So in this case, as I click on the button, because the button has a depress CSS style, the browser has to physically repaint that section of the screen. Or as I'm scrolling through here, well, this is all done using CSS transitions, but so hopefully there aren't too many areas being repainted in that case, but as I'm adding or removing items from the DOM, it'll highlight where those things are. So there are a whole slew of other features that we could literally spend the rest of the week talking about, but I'm going to encourage you just to go take a look at that on your own. The last thing I wanted to point out may not be quite as hidden. You still have to go digging for it, but on your Sources tab, let me turn off emulation now. You go to your Sources tab, I'll hide my escape drawer. I think everyone's familiar with or if you're not already familiar, you should be familiar with the pause on exceptions button. So it's this little stop sign looking thing that you can hit, and rather than allowing the application to fail when it hits an error, and as an example, let me throw in an error. So I've now introduced an error into my JavaScript, and if we switch to my console, it'll tell me, oh, foo is not defined, and it gives me a nice little stack trace, even tells me where it is. But wouldn't it be cool if you could just pause on exceptions and rather than failing, actually allow the debugger to stop before it throws the error, and then you can inspect what's in that context at runtime. So that's pretty neat. Let me show you a better example, in my opinion, which would be here. I don't know if I refresh. For the sake of argument, I go to run a method perhaps inside of set timeout. So set timeout is run in the context of the window. And maybe this is a callback for an AJAX request. So ext ajax.request, and you give it either a callback or a success or a failure handler. All of those callbacks are executed in the asynchronous sense, so you don't get the nice call stack. So right now we can see, looking at my call stack when I pause on the exception, there's only 2 items here, where the actual error is and then the function that called it, which in this case isn't exactly helpful. Wouldn't it be great if you knew where in your code that asynchronous request was made, so that you could figure out what was in the context of the runtime at that point? And so there's a little async checkbox on the call stack, which if I click through here and then hit that error a second time, not only do I have those first 2 steps in the call stack, but then after it tells me, oh, that's from set timeout, I can now continue going backwards in time until I figure out, so that was from some other callback that I did, and walk this all the way back up the chain so that, okay, this is inside of some method I have called load store records. Extremely helpful. And I'm hoping you've already found that, but if you haven't, that's been life-changing for me. Okay, so that's Chrome DevTools, and again, I'm hoping I showed you a few things that were new. What I'd really like to talk about would be the fact that Chrome developer tools, and by proxy, Firefox developer tools, or the developer tools in the other browsers, they're really great at telling you about your code, but they know absolutely nothing about your application. And so building a extension of Chrome developer tools may allow you to more intelligently debug an application. So if you look at the architecture of how a Chrome developer tools extension looks, and I apologize, this isn't big enough for some of you in the back, but it essentially is three parts. There's the inspected window, which is physically your application. It has nothing really to do with developer tools except that you're inspecting it. There is a background page, and I'll come back to this in a moment. And then there is a developer tools pane, in which is the extension you've built living inside the context of Chrome developer tools. So let's explore what each of these different parts are and what they mean, and then we'll actually build a Chrome extension here on stage. So the background page is part of every Chrome extension. It is often a common need of an extension to have the ability to manage long-running tasks or manage the state of the extension itself. And that would happen within the background page. And what's interesting is that even though you can have Chrome developer tools open on multiple tabs within the Chrome browser, your extension will only ever have a single instance of the background page running, even though you'll have multiple instances of the developer tools pane on each tab. So it's a bit confusing, but really the best way to think about the background page is having a message bus that manages either the instances of your extension or managing state and proxying information via post message to the inspected window. The inspected window, as I mentioned, is your application. In the context of this discussion, it will be a Sencha app, but really it could be anything. And what you have to realize about building a Chrome extension that inspects your application is that the extension has the ability to execute code in the context of your app, which, if you think about it, is really a gigantic security hole. So you have to be careful about setting up your Chrome extension if you're going to deploy it out for public usage, but if it's just something you're using internally, perhaps that's less of an issue, but still something to be aware of. And finally, the DevTools page, or the panel within Developer Tools, is the interface you are going to build to display information about the inspected window. And I feel this is a really good analogy here, where if you think of an application as a cat or a dog, Chrome developer tools can tell you that the fur is orange because that's styled via CSS, or one of its claws broke because it throws an error in the runtime. But Chrome developer tools cannot tell you the cat likes its ass scratched the most, because clearly, I don't know if you can see that, but the one spot that says hell yes is right above the tail. So that's what your Chrome extension has the ability to tell you. And that's why it's so important to understand how to do this, because it'll make your lives very, very easy to start debugging your own applications. So very quickly, let me dive into my IDE, and let me make my text a little bigger. I should have done this earlier. And I'll close out of these two files. So what you can see over here in my project tree is a really simple Chrome extension. It involves this file called manifest.json, which, if you're familiar with building like a node package, you'd have a package.json file. It tells you the name of the extension, In this case, what permissions you're allowing it to have, if there are any resources that need to be loaded with it. You would define that in your manifest.json file. Also very similar to your app.json in a Sencha application. And if I quickly show you what that looks like, again, it'll tell you what the name of it is, if there's a minimum version of Chrome it has to run in. But really, the important part here is defining where it can find the background page and where it can find your DevTools page. So you'll see that I have my background page under a background folder, which is over here, and my DevTools page, which is under a DevTools folder. So this is fairly simple. I'll show you what the background HTML page looks like. It just includes a JavaScript file. I'm not even sure why they make you create an HTML page, because you can't actually see the background page. I'm not sure if there's a better way to do this, but that just includes a script file, which doesn't actually have to do anything. So in this case, I just have it for the sake of example, and because you have to have a background JS file. If you don't, your extension won't work. The Developer Tools section of this has two of its own separate interfaces. The first is that it loads up, again, a mechanism to load two separate files. One can be the interface that's its own unique tab within Chrome Developer Tools, and that one is called panel. So we'll look at that first. And the second is that you can create sub-tabs of the other Chrome Developer Tools tabs. So if I wanted to create something that sits inside of the Elements tab, where you can inspect your DOM tree, you can do that too. And I'll come back to that in a moment. I realize this is slightly confusing. The panel.js file calls one of the Chrome APIs to create a brand new panel on your Chrome DevTools section. In this case, I'm going to call it Sencha. I'm going to tell it to load this HTML file. So that's going to be the actual interface that people can interact with, or where I want to display information. And then it gives me the ability to have a callback method where if my background page were doing something interesting, maybe I want to send messages back and forth. This might be really useful, as I mentioned, where you only ever have a single background page, but you can have multiple instances of the DevTools panel. And so if you want to manage what happens when the page refreshes, perhaps you don't want to refresh every instance of the DevTools panel on other tabs. You only want it on the tab that is actually refreshed. This is where you might manage that logic. And on the opposite side, inside of the Elements panel, so you can call this Chrome API devtools.panels.elements, and I can create what's called a sidebar pane. And again, give it a name. And then it doesn't really allow you to create a physical HTML interface. This might be a better place for outputting raw objects that you want to interact with. So we'll come back to that in just a second here. If you then want to load this extension in Chrome, you go to Tools, Extensions, and you could go through some sort of build process to create the necessary format for a Chrome extension, but you can also load it directly off the file system. And if I come and find that, you can see I'm just loading the parent folder of the extension I just showed you. That loads here. Let's close Developer Tools and reopen it. And so now you can see I have a tab called Sencha, in which I just say, look, ma, custom DevTools pane. So nothing really interesting to see here, but you understand the implications, that you can build an interface and then communicate back to the window you're inspecting, and you optionally display information or execute arbitrary code, all sorts of fun things. Inside the Elements tab, I now have a custom panel. Maybe that's hard to see, but custom panel exists right there. I don't actually do anything inside of it, but you can see this is inside of the Elements tab. So I'm mousing over the DOM elements, and an idea here might be if you click on a DOM element, maybe inside of your custom panel, you want to output a JSON representation of that DOM element, or in the case of a Sencha component, maybe you want to output information about the Sencha component you clicked on via the DOM tree. So that's your crash course in building a Chrome extension. So let me give you perhaps a more concrete example, which is this project called App Inspector for Sencha. And I apologize for the confusing naming here. You all heard about Sencha Inspector in the keynote, and I'll show that to you in a moment. That is not this thing. This is a Google Chrome extension that was written primarily by me with the help of a few other individuals. You can get it for free in the Chrome web store. And all of this code is available on Sencha Labs on GitHub. So you can go take a look at it, see how we built it, add your own functionality to it. And I would encourage you to do that. To just quickly show you what it does, I need to turn it on. So I'll go into my extensions, I'll turn off my custom, and I'll enable App Inspector. Reopen my developer tools, and then over here, I now get a Chrome extension. This is built with XJS that tells me information about my Sencha application. What version I'm using, what the application namespace is. If I have any other packages that are loaded into ext versions, it'll display that information here. And we can walk down the component tree, so I can find a container, click on it, it'll highlight it on the screen. Over here on the right, it'll tell me what properties and methods are defined on that component. If there are any stores loaded, and I don't have any stores in this example, but you could inspect the data stores and the individual records that are in each of those stores, so that can be very useful. We have the ability to profile various troublesome layouts. So raise your hand if you've ever been in a situation where you've over-nested panels. Okay. I am very guilty of that myself. So we have a couple of profilers to tell you if you're using box layouts incorrectly, if you've got a V box inside of an H box, inside of another H box, perhaps you should revisit that. So we would identify that here. Or if you have an over-nesting of panels, we can analyze that as well. If there are events that are happening on the screen, you can record that. And I have done something to anger the live coding gods, but trust me, that usually works. You would be able to see any events firing in the application, what components are firing them. So that can be very useful. And then last but not least, if you're using Model View Controller, you can inspect what controllers are available in the application, what events they're managing. So it certainly isn't free of bugs. We've tested this across Sencha Touch 2 and above and XJS 4, and it seems to work really well across both of those two frameworks. It works relatively well with XJS 5, but I haven't updated what's in the Chrome Web Store to fully support that. So if you're using XJS 5, be aware that it's probably more buggy than if you were using XJS 4. So that's App Inspector for Sencha. And as I mentioned earlier, Sencha Inspector, which you saw in the keynote, grew out of a lot of lessons we learned building this Chrome extension. So what I would like to do would be to show you Sencha Inspector. And one of the immediate limitations you may notice about the Chrome extension is that it only works in Chrome. And so we got to thinking, wouldn't it be great if you could debug an application in Firefox, debug an application in Internet Explorer or Safari? Perhaps you want to debug something running on a remote device. Maybe you want to debug something running inside of Sencha space. There are other hypothetical scenarios I don't want to overpromise that we support, but you kind of see the idea. So let me click into one application. This is an Next.js 5 application I have running here. And so you can see the URL is running on localhost. Oops, I don't know what that was. Ooh. This is running on localhost port 9003. And if I come back to Sencha Inspector, which by the way is a desktop application running on Mac OS X. So this is not running inside of a browser. This is a freestanding application. I can click on this particular app. And if I move some things out of the way, as I begin to interact with this, you'll see on the Components tab, I can click and it's still going to show you what components you're interacting with. When we do this in a different browser, maybe perhaps this will be more interesting. I'll open up the iOS simulator. And so this is running against my machine name. So I couldn't actually get my iPad to connect on the Wi-Fi network here to my computer, but if you were on a less busy Wi-Fi connection, this would work just as well. So this is inside of Safari on the iOS simulator. See, it's running off of ArtMac local 1841. If I come back to Sencha Inspector, you see that I've got that running here. It identifies it as Safari. It even tells me it's running Safari browser version 8, XJS 5 application. And as I begin interacting with things here, you can see it's now highlighting things inside of the iOS simulator for me. But we also wanted to go quite a bit further than just doing the functionality you saw inside of the Chrome extension. So the Chrome extension offered a lot more debugging capability than we ever gave you before. But we didn't want to stop there. We kind of got power hungry and said, ooh, there's lots of cool stuff we can do here. One of which in Next.js 5 is the ability to look at view models. So this particular application, you can see there's an icon here in the grid that tells me this has a view model. And if I click on the view model over here, I can see what data is defined in that view model. Or down here, I can see that there are data bindings. So we have these awesome little data binding icons. It'll tell me what is being bound in that particular component and what its value is. Did anybody in here attend Stan's presentation earlier on visualizing the component relationships? Stan did a really good job there. The team at Modus worked with us to implement some of that here in the application, where you can see I've clicked on a container. Container inherits from ext component, but it also has a mixin. And you can walk that, walk that all the way up the inheritance chain, so you can know exactly what is built into that particular component. Again, if you had any data stores in here, you could inspect the data. Let me choose a different application that may have some data in it. I don't have one running. So maybe this one. Okay, so we didn't register the store for this grid with the store ID, so it doesn't show up here. But again, if you had any records in the store, you could inspect them. We also went a step further and said, well, if we can show you the relationships in inheritance, why can't we show you any model associations? So if I had an example running, we have a tab over here to view the relationships for your model associations. Again, things like layouts, the same stuff I showed you before, eventing. Let's see if events work here. Yeah, so it records all the events, tells you where they're being fired from, the component ID, what kind of event it is. You could filter that down for particular kinds of events. Again, MVC stuff. So we think this will be super useful. But again, maybe some of you saw the fashion talk yesterday. I think Phil showed some of this awesome sauce. That if you're using XJS 6, you'll be able to start live editing your theme. So for example, I can filter down for base color. And you can see up on the upper left where it says X6QA, that's this awesome blue color. Maybe I prefer some sort of orange. Let's find a prettier orange. And I can hit OK, and instantly it updates. But it's not just the base color, it's everything that inherits from base color. So it literally regenerates your theme in a split second. So while we haven't completely worked out what this will mean for building a theme, you can filter down by what values have changed. We're going to work towards a way to allow you to either export these changes or somehow save that locally. I don't know what that will end up looking like, but we know this will be very powerful for you. And last but not least, while I don't have an example of this, we're working towards in Sencha Space the ability to inspect any of your secure files and the data stored inside of the secure space runtime when you're using the debug client. And clearly, we're not going to open that up for the production space client because we're all about security and we don't want to open up security holes, but lots more cool stuff coming down the pipeline. So that was my top secret demo. Okay, so I basically skipped all this stuff because we all like to debug code. I only have a few minutes left here, so questions? Feel free to come on up to the microphones.
Does DevTools support debugging CPU performance in web workers?
Does Chrome DevTools out of the box support debugging web workers?
Right.
I would be lying if I said I knew the for sure answer there. I know somewhere in Chrome DevTools I've seen the word web workers, but I haven't ever actually tried to use it. The one thing I will say, Paul Irish and the DevTools team have done a great job touring the conference circuit, doing talks, and inevitably there's a YouTube video out there, but unfortunately there's very little actual documentation. So I would encourage you to do a little bit of Googling and see what you find, but you may be stuck with a YouTube video for an answer.
Gotcha. Thanks.
Has there been any talk at Sencha about using what you're showing us with the inspector and changing the theme to empower the user experience team to sort of move the heavy lifting of theming out of the hands of the developers and make it more of a creative activity so that the UX team can involve the theme and play with it and save it off? I'm just wondering if that might be where that would be awesome.
So for people who may be watching the recorded video who didn't quite hear that, the question is, rather than doing theme editing in a development sort of environment, have we thought about giving the creative team members the ability to work with theming, perhaps not inside of the Sencha inspector, but through some other mechanism? Is that accurate?
Well, I could imagine how if you had an API for Sencha
Sure, okay, so we have given some thought to that. We're not nearly far enough along in the discussions about what that might look like. I'm hoping once we get closer to XJS 6's GA that we'll be able to have a more concrete idea for you. I can tell you that all ideas are on the table for this right now, and that's certainly a good one. But I don't have a satisfactory answer for you right now.
When will the inspector be available for download?
I knew that question was coming. When will Sencha Inspector be available? I don't know. So Sencha Inspector has come a long way, clearly, since the Google Chrome plugin. But one of the things we're very cognizant about at Sencha is that we're already making you download the SDK. You have to, in most cases, get Sencha Command. Maybe you're using Sencha Architect or the new IDE plugin, or there could be any other number of, installables coming from us. And we are trying to figure out a way to more succinctly distribute our binaries to you. So at some point, probably around when XJS 6 GAs, we'll have an answer for that and hopefully some sort of beta to give you. But I don't know what it'll look like, if it's going to be bundled with another tool or if we're going to make you install it on its own. Those questions are going to be answered internally over the next few weeks, and I hope to have an answer for you soon.
Does Sencha Inspector have putting a breakpoint and doing debugging?
I didn't
Putting
know.
a breakpoint and debugging abilities, the Sencha Inspector.
Does it allow you to put breakpoints in? It does not currently at the moment, primarily because Google Chrome Developer Tools already allows you to do that. It would be interesting to do that for remote debugging environments, perhaps if you're inside of Sencha Space or if you're debugging something on your iPad. While I won't promise we'll do this, one idea has been, since Chrome Developer Tools are actually open sourced, we could simply fork their repo and pull out whatever bits we want to and hook them into our own APIs. But right now, it doesn't make sense to reproduce the wheel for a smaller subset of use cases. Maybe we'll revisit that.
I was just curious how you did that thing where you zoomed in on a really small portion of your screen.
I believe you go to one of your settings in, well, come up to me afterwards and I'll show you. Yes, that's a neat little trick I learned yesterday. Other questions? I think I maybe have another minute. Okay. Well, if there aren't more questions, feel free to grab me throughout the rest of the day here or on Twitter. Thank you very much.